Hello, Calculus and Vectors class. We are now at 6.4, derivatives of exponential functions. We have one more big rule to learn, and it's your last rule of calculus. So enjoy it. So if we have a function y equals b to the power of x for some constant b that's our base, the derivative is going to be the natural logarithm of b times b to the x. So it actually looks very similar to the original, except we're just multiplying it by the natural logarithm of b. So it's not a horribly difficult rule. So let's try doing some differentiation. So if we have y equals 3 to the x, then we're going to have dy by dx is going to be natural logarithm of 3 times 3 to the x. Let's try a different one. That doesn't seem too difficult. Let's try e to the x. So remember, e is that special number 2.71, and we were asking why that's special. So let's take a look. So if we apply the rule, it's going to be natural logarithm of e times e of x. But think back. We said there's something special about natural logarithm of e. Take a second, punch that in your calculator. I'll give you a couple of seconds if you don't know already. Hopefully you've realized at this point that natural logarithm of e is equal to 1. So in this case, it's going to be e to the x. So hopefully you're realizing the significance of this right now. Take a look. Our original function was e to the x, and our derivative is e to the x. And in fact, e to the x is the only function in all of mathematics for which this works. It's the only function where the derivative is the same as the original function. And that is the reason why e is a special number. Just like pi has significance, e has significance, and this is why. So keep that in mind, because you never know when that might come in handy. So example 2 is asking us to find the equation of the line tangent to the function y equals 2 times e to the x at x equals natural log of 3. So we've done tangent problems. I think we've done them to death, but let's do another one. mx plus b. So we need to find our different values here. X, we said, is going to be natural logarithm of 3. Y is going to be equal to, we're just going to take 2 times e to the natural logarithm of 3. And think back, we said according to our rules, the natural log and the e to the power of cancel each other out. So it's just going to be 2 times 3, or 6. So now we just need to find the slope before we can solve for the y-intercept. So the slope is going to be y prime at x equals natural log of 3. So let's find y prime. So if the original function was 2e to the x, the constant multiple rule still applies. So we leave the constant multiple the same, and then we differentiate the other part of our function. And since the derivative of e to the x is e to the x, it stays the same. So as it turns out, in this case, it's going to be the derivative is 2e to the x, or e to the natural log of 3. So again, that's going to be 2 times 3, or 6. So now that we have that, we can plug that information in and try and solve. So y is 6, m is 6, and x is natural log of 3. Let me tie that up a bit. Natural log of 3 plus b. So now we just need to move that over. 6 minus 6 natural log of 3 equals b. Let's common factor just to make it look a little bit nicer, because we know that we can common factor at those 6's, and that's 1 minus natural log of 3. And you know what, this is probably okay, but I want to make it look a little bit neater, so I'm going to do one more little trick. We said 1 is the same as the natural log of e minus the natural log of 3. And we said that one of our logarithm properties is that if we're subtracting two logarithms, we can combine it and turn it into a fraction. It's actually just that one, the subtraction rule in reverse. So in this case, our y-intercept is 6 times the natural logarithm of e over 3. So now we have the slope, we have the y-intercept, so our tangent line is y equals, slope is 6x plus 6 natural logarithm of e over 3. That's all there is to it. Same basic principles, just the differentiation looks a little bit different. But overall, not too much more difficult than you've seen before. Just as long as you know how to work with your logarithms, then you're okay. Example 3, we're going to do an application question now. A biologist is studying the increase in the population of a particular insect in a provincial park. The population triples every week. Assume the population continues to increase at this rate, and initially there are 100 insects. So question A says determine the number of insects present after 4 weeks. So first of all, let's try and make our equation. So let's set some variables here. Let's say let P represent the population of this insect. Whoops. And let's T represent time. And let's say in weeks, just to be specific. So if that's the case, we can set up our equation. So P of t is equal to, our initial value is 100, so it's going to be 100. And then we said triples, so we're going to worry about the tripling rates. So our growth rate is 3. And it's going to increase, it's going to be to the power of t. So now we just want to find out what happens after 4 weeks. So in that case, t is equal to 4. So let's do p of 4. That's going to be 100 times 3 to the 4, or 100 times 81, or 8,100 insects. So the next question is asking, how fast is the number of insects increasing when they are initially discovered? So when it says how fast, that's rate of change. So think derivative. So we're looking for the rate of change of the population, or p prime of t. So we're just going to take p prime of t. Let's find the derivative first. And we said that's going to be, the original was 100 times 3 to the t. So we're going to do the derivative. That's 100 is the constant multiple, so that stays the same. And we said for 3 to the t, that's going to be natural logarithm of 3 times 3 to the t. That's going to be 100 natural log of 3 times 3 to the t. So when they're initially discovered, that's going to be times 0. So we're going to find the derivative at 0. That's going to be 100 times natural log of 3 times 3 to the 0. And of course, 3 to the 0 is just 1. So it's going to be 100 times natural log of 3, which is 109.86. So I'm going to say we don't want a part of an insect. So we're going to say 110 insects per week, roughly. So 110 insects per week is the rate of change when we start. At the end of 4 weeks, we're just going to find the derivative at time at t equals 4. So that's going to be 100 times natural log of 3 times 3 to the 4. So that'll be, punch in your calculator and you get something like 8898.75. Let's round that up to 8,899 insects per week. So again, the same basic principles apply for solving any other type of word problem. You just need to know how to differentiate your function, figure out what it's asking for, and know if it's asking for your derivative. And as long as you know how to differentiate using exponential functions, then you are set.